Welcome to Ask and Learn.
So if we want to find y prime, um, we could try to take the derivative of this directly, but one thing I want to do is first apply e on each side, and you'll maybe see why I want to do this in a moment. So this is going to give us e to the y is equal to x squared plus y squared. All right. So now what I'm going to do is go ahead and take the derivative here. So we have d by dx. So on the left side, we'll have to apply chain rule to this. So it would be e to the y times the derivative of y, which is just y prime. And then over here, we'd end up with 2x plus. Then the derivative of y squared, we'll have to use chain rule as well. So it'd be 2y times the derivative of y, which is y prime. And now we can go ahead and get our y primes on the same side. So I'm going to subtract this over. So it would be e to the y times y prime minus 2y y prime is equal to 2x. Then we can factor out the y prime, so we get y prime um, times e to the y minus 2y is equal to 2x. Then we can go ahead and divide this over. So we'd end up with y prime is equal to 2x over e to the y minus 2y. And so now this, I believe, looks a little bit different from what they give you as the answer in the back of the book. Um, so let's go ahead and rewrite this so we can get it to look more like that solution. So in the solution, they have this 2x in the numerator and the minus 2y there. So all we really need to do is somehow get rid of this e to the y. Well, if we come back up to here, notice how we have e to the y is equal to x squared plus y squared. So we can come down here and just plug that in. So it'd be y prime is equal to 2x over x squared plus y squared minus 2y, which is exactly what we were given. So, I mean, both of these are valid solutions. I mean, the only reason why I really rewrote it in this way is to make it look more like the answer in the back of the book. But you can write it as either one of these, and these are still valid solutions. If you were to have just taken the derivative directly, so like if we didn't do this exponentiation of e on each side and just did the derivative directly, then you would have got this second one a little bit more straightforward. But doing it, there was a lot more algebra involved. So that's why I preferred to do it this way. So yeah, I would encourage you try to do it the first way more directly, and then you would see that, oh yeah, doing it that way is a lot more work. But yeah, I mean, either way though, you get the same answer.